So hello, thank you for joining to this meetup. I will be talking about our development processes, maybe not only just development but also deployment. And I would like to even show you how we are leveraging the power of Kotlin and our journey throughout the time that we've been building our services and used Kotlin for it. So first, before I will make or start the presentation, I would like to show you a safe harbor statement. So I really hope that you will be able to read it shortly. So I definitely believe that you've been reading the whole statement. So now let me go for the presentation. So my name is Kaspar. I'm software engineer here in Workday, based in Prague office, and working on the application that you already stated, or it was stated by Honza. So for today, I have mainly two kind of things that I would like to talk about. So how we develop and deploy the applications, and second one is how we leveraging, or where is that Kotlin, where we are using it. And of course, if you will have some questions, I will be happy to answer them if any will be. So first, in general, how we developing. I will not go through how we creating pull requests. All of that is most likely the same for most of us or all the companies. But instead, I will be just focusing rather on what are the key things that helps us to really deploy the system to production and make our product to the customers. So first key feature that we are using is featured flag. Most likely if you are working on some enterprise application, you definitely have some sort of that feature that allows you to kind of smoothly release your product. This allows us basically building our source code and new features while not having all the features enabled to all customers until we are confident with them. In specific, we are able to more fine-grain control of that flags, and we can control it for each individual tenants. We base the confidence levels on how much we trust certain feature that is feature ready, development ready, the production ready. So we start with something that is in off state, which means we are not confident, we are building the feature, and once it is built, we get it into testing phase or testing confidence level. We basically just handing over to all internal people, and we can test it properly and from all angles. Once we get it, it gets into preview where we get the confidence and we want to show it to our customers. They check it, they provide maybe feedback, and on top of that, we finally rolling it out to production. Note that we have even custom confidence level, which is sort of a way how we can express way more complex logic, not just stating it's ready to production things. So we can have way more parameters that allows us to determine it. Next thing, of course, we coding. We are coding and storing our source code in the versioning system. Specifically, we are using 3 code lines. Most of the companies, I think, are storing or using the similar pattern. So in our particular case, we are having main code line where we store and basically have all the changes, including bug fixes, latest changes, features, everything goes there. Once we are ready, we typically, or once the time that we would like to about to release, we creating a release candidate, and again, that's something that is supposed to be used and tested before we release. And then we have hot patch, which represents the actual source code that we are releasing. And of course, we are even using the tags to qualify whether certain feature or certain code line is ready to be used in the next stage. So maybe more visually, you can see that we basically have the main line. We have features that are merged into the main line, and once we merge something in, we immediately start the CI builds. Once the CI builds with all the tests and whole suite of tests that we have is validating the builds, then we of course mark that particular thing with a tag that is for qualified main. That is finally that marks the point that we can use for branching off or cutting off our release candidate. And of course, that release candidate is used maybe for testing, maybe for hot patching, RC patching if needed. And again, there is a series of builds that are ensuring that we have something which is fulfilling the quality criteria that we need.
Are you using monorepo or single repository? Or
no, explicitly no, because there are many things that we are building that thing, and it would be possible if I know that, for example, Google has a monorepo. In our company, we don't have. Individual teams are independent. So yes, typically each service has its own repository, and you just do your changes. Know that, of course, we can deploy individual services independently, or they should be not relying on each other's version or anything like that. So basically, we rather prefer contract-based APIs between the services rather than specific version to bind it with. So,
sorry, how do you go about shared dependencies like libraries or?
So again, we have some Git repositories that are having and are dedicated in the library for libraries, and then they get exposed or built as an official artifact into some artifactory place where you store all the artifacts, and of course then we have it as an official dependency to our project. So that's it. So now what I would like to explicitly highlight that we are not automatically pushing everything to production. Some big companies are doing it, but to do so you need to have very, very extensive suite of automated tests that would ensure that none of the PRs would be really passing through that would even potentially can break it. So we explicitly have this sign off to approve by development and quality department that really it is something that is well tested and have good quality. So again, once we have it, we get it into production code or hot patch code line, and once we have it there, if needed, we can hot patch it, and of course we are tagging it for understanding which release has been released when. So note that we are explicitly tagging everything, not branching specific releases. So next and last thing that contributes to the whole way how we getting things to production is the environment. So we have various environments. Most of the companies, of course, have something which is dev, test, maybe staging, maybe production. So we have the same. Maybe one small thing that I would highlight is that we have something called sandbox. Sandbox is introduced just for the simple fact that your simple service that you getting is usually need to have some coordination. You would like to have some environment that you see and integrate it with the rest of the services. And if you would like to have such an environment, you cannot install it on a single machine. Basically the whole ecosystem of the products is so huge that you can't just put it on your single machine. So sandbox you can imagine as a cluster, sitting somewhere in the cloud that is dedicated to you for your need, and you basically can connect your service, locally running service, to that cluster and pretend that your locally running service is actually connected to your cluster and runs within the cluster. So this way you can even, for example, locally debug your code while it is pretending to be in kind of production-like environment. So, but again, otherwise, we have all these typical environments that you might think that typically is used. So I haven't stated so far how we are releasing. So we have several waves of releases. So actually we are releasing every single week. It doesn't mean that we're releasing new super big features every single week, but it's rather that every single week we are able to provide maybe new minor tweaks, maybe configuration changes, maybe bug fixes. Then when we have something which requires slightly more change, we usually use the feature flags. So it doesn't mean that if you have some feature, you just code it in production code. No, we have it under toggles or this feature tags, and in that case, you have it off, and then you slowly progressing your confidence level. Once we get it into the moment that we want to release it, we typically coordinate the releases across multiple features. So that's why we are coordinating and collectively putting multiple of these feature flags to be changed on quarter basis. So that's when you really get some valuable feature for you as a customer. Know that this is something that we use rather for incremental changes. So it doesn't mean that it's something super huge, massive feature that is being publicly announced as some very important feature in our product. For that, we are actually coordinating across the whole Workday company, and basically we are having the schedule of releases typically biannually. And that's where you really get something customer-facing feature that you can look at. So next one, how is it with the deployment? Very quickly, just everything is Dockerized. Every single service is having its Docker image, which is then deployed to our clusters. We are trying to have single version of our every single service that we have. Is basically simplifying the whole maintenance and deployment process, to not have dedicated various environments with dedicated specific versions that you're deploying. We typically have two clouds. One is private and one is public. Reasoning is just to provide the options for our customers where they want to deploy it, and by that we also have different way how we deploying things into the cloud. So private cloud, we can manage it slightly differently, and we have the possibility to do and have planned maintenance window in which we actually redeploying our services during that window. In public cloud, we actually expecting that it will be zero downtime compliant, and therefore it will be leveraging the rolling upgrade strategy. So basically the service is up and running all the time, and there is always one server up and running. So you already heard that we are building people analytics or the new applications for analytics. Actually, analytical applications are having very crucial thing that you need for them, and that's testing data. Without testing data and good testing data, it's very hard to validate your product whether it is behaving correctly. For testing data, you can kind of have a portfolio of ways how you generate it. First thing that comes to your mind might be just that you handcraft the data. This is typically thing that you do as for your unit tests. Even if you have any business logic that you want to you want to build or create. This is fine, but for analytical purposes, this is very, very tedious process because it's not just one line or a couple of parameters, but it's usually some data set that you need to work with. Maybe 10 lines, maybe several hundreds lines of data. So you can see that it might be quite challenging to build it. So for that reason, there are many, many tools. And just one of them is an example of mokaru.com. I'm not advertising, but this is just an example which you can use. And there you actually create the data slightly differently. You just define your schema. So you just say first column is, for example, first name, second column is last name, third column is the age, and it just generates a huge quantity of data just based on the description of the data model and how you're generating the particular thing. Well, is it enough? And I would say no, it's not enough for our purposes, because in analytical space, it's not about the volume of the data. It's about that you discover some analysis or something important in the data. And in our particular case, we're discovering patterns. So what we need to have is somehow easy way to generate certain data volume of data that would have certain patterns that we want to make sure that the algorithm will detect. And for that reason, we are having third way, or you can even implement the third way, which is pattern-based automatically generated data. By this, I mean you generate data and you describe in them, for example, that I want to have maybe 1,000 records, and in that 1,000 records about employees, I would like to, for example, in certain population, raise the salary of, from, 3 months ago. Or you just define different patterns, and you're just defining the patterns that the data should be modified with. So when the data are generated, they are not just random noise. They contain those patterns in it. So where we are actually in our company, we actually leveraging all three accesses or all three approaches, because each of them has value for different stage of our development. So first one is that actually, of course, handcraft typically very commonly used in unit tests. Very small amount of data because it's hard to build it and maintain it, but it's possible to do it, and usually you can really fine-tune that thing very easily for the particular use case. Auto-generated data, that's where we want to have, or it's used for performance tests. And why? Because we want to have a huge amount of data that needs to be processed throughout the whole stack, and we can verify whether the performance of the whole stack is fast enough. Typically used for ETL processes, where we have multiple transformations of the data, and we just want to know whether it will perform. Next one is, of course, the pattern-based matching. And that's exactly because the auto-generate is not fitting. Typically, auto-generated data are basically white noise. They don't have anything significant in it. So pattern-based, actually, in contrary, is having the patterns in it because you encoded what patterns it should have inside. And yes, it might generate even higher volume of data, but it doesn't make sense to generate really billions of records, because it's matter only on the number of patterns that you put into the data that you want to detect, right? So I'm positioning somewhere in the middle. It requires you to not just define the schema and just generate whatever volume. You need to fine-tune the patterns that you want to have so it can be detected. So it requires some maintenance, but then yes, you can use it for these kind of analytical thing. Where we're using it, again, it's good for end-to-end testing because you can just define your pattern and then test that the end result is really containing that that content and that pattern detected, and of course for demos because you will show up the real use case. So this was so far about in general how we're developing and deploying our system, and I will start talking rather about Kotlin and our journey, how we've been using Kotlin and how it helped us to achieve all these successful products. So first one, where we are using it. First thing that I want to let you know that it is JVM-based libraries and backend services. We do not use multi-platform targets. So main primary reason is that basically Kotlin for us is very good for the backend. For the front end, we have already established frameworks for mobile applications, for applications, and we are using that frameworks there. From Kotlin, of course, we use Kotlin by itself and several supporting tools and libraries. So I will go through some of them throughout the presentation. Now, how it all started. I will not be talking about individual Kotlin feature because most of you most likely know it, but instead why we decided to go for Kotlin. So it was started actually as an experiment. 5 years ago, we just were tasked with developing a new service, and we've been thinking about principles of how we will be developing the service. And it was very interesting that actually our principles, how we wanted to develop the application, was matching what the features Kotlin offers. Specifically, I would name that, yes, it is able to cooperate with the JVM or Java-based libraries. That was crucial for us because we have a huge set of libraries even today. We really like the concept of immutability, data classes or schema defined by the data classes. Very nice, readability of the code just by having so many convenience methods, as well as, of course, coroutines that we use for parallelized calls to external APIs. So basically, in general, we really like the Kotlin, and it was hard to say which feature we don't like. Actually, we liked all the features. So now I would like to show you our journey, specifically what we've been using and what we've been maybe even slightly needed to understand and experience with. So, and what was our finding. So specifically for coroutines, we are using them for calling external APIs. And it's perfect there because it just simplifies the code and everything is nice, but we are not using it for heavy computation. So there we still, using the threads because we want to just have it completely under our control. Of course, we like that the coroutines are nicely integrated into the whole Kotlin language, but on the downside is that it's so nicely that it seems like that it just works out of box. And if you don't know what exactly is happening, in certain cases you can make quite very, very bad mistakes. And one of the mistakes I would like to just show you here at the bottom, that basically you need to make sure that you are really understanding that there are thread local variables and you properly passing it to coroutines. If you don't do it, you can just have huge problems to your application. Typical example, I'm just listing these two. Of course, you can think of billions of others. Maybe MDC is used for logging, right? So you provide some additional parameters for your logging. If you don't pass it to the context of those coroutines, you are incorrectly printing the logs. They are maybe using the logs annotated for different thread, for example. So very crucial to not forget about this. And that's why I'm just saying, it's easy to make a mistake if you forget about this. Next thing, which was quite surprise, I have to say, one day we've been, of course, using Kotlin for a while. We've been using it with Spring. It was working perfectly, but one day we had a requirement to have a request scope information to be kept. So throughout that time, we just said, well, that's easy. We just create something that is on the first block at the top. Basically, let's create some data class or class in Kotlin. Let's create it as a bean and define it as a request scope. We started it, and actually it failed. And we expected that it will create single instance per request, as any other Spring application would do normally. But actually it didn't. It was just a single instance per all requests. And that's a huge problem, right? So we've been looking into it, and actually the solution was quite simple, But what was also interesting that if you just change the Kotlin class from Kotlin to Java, it would just immediately start working, right? And again, puzzled with that, we kind of investigated it, and the solution was simple: just change that bean to component. So see that the code change is almost not trivial, right? But then it completely changes how Spring is handling this piece of code. So in first one, basically Spring is using cglib to create the proxy instances. That is basically providing you that instance to your application when needed. And in this particular case, it is basically calling this method to get you the instance of your class and then wrapping it with another instance, right? In the second example, it's completely different. It is that you have a class. Kotlin creates, Spring creates subclass, which is representing that proxy class, and then it creates the instance. And that was the difference between those two patterns. And again, the second pattern perfectly works. We are happy, it works. It's actually even listed in the official documentation for Spring for Kotlin extensions. Actually, even recently, like, 5-6 months ago, there was a Jira file for it in Spring forum, and actually it is quite interesting to read it because there was an explanation of thought process why it is happening like this. So if you are interested, feel free to look at it. So next one, we really like the how Kotlin provides nice convenience methods. So it really makes the source code nicely readable. But we on purpose do not use some of them. And specific reasoning is, for example, in this particular case, see that if you use, for example, first method, you calling it with some assumption that there is at least one element. If there is no element, you throw an exception, right? The exception is quite generic, and the assumption will hold, but you can imagine that in large-scale organization, it may happen that you have certain assumption, but certain different team maybe didn't kept or understood your assumption, right? So they might change the code the way that the assumption no longer holds. In this particular case, if you use the first example, you don't have any trace of how to find out what might have been root cause. In the second case, which you just replace it with first or null and you throw your own exception, then you can provide more additional context. So, for example, name or ID of the company, or maybe backtracing the issue to the original source. So that's why we on purpose using the second approach only. Another surprise, it was that actually we like smart casting. We see that it's quite powerful. It simplifies the code. Everything is great, but it's sometimes not working. And we discovered throughout the time that we've been using more and more features from Kotlin. So in this particular case, we just started to leveraging sealed interfaces. And from that, you derive your data class. Perfectly well-established pattern in Kotlin, there is nothing problem with it. But when you start using it with smart casting, it is not working. And you might be questioning why, because even interface, even the subclass is containing value properties, so it would be expecting that it will just work, but it is not. And reasoning is simple, because the interface is representing the property as a getter method. And Kotlin doesn't expect that calling a getter method would return the same value every single time. So that's the reason why the smart casting is not working in this particular case. It's not a critical issue, of course. Workaround is very, very simple. You just introduce it as a local variable and use the local variable instead. But you can imagine that if there is huge structures in your source code, you're creating many, many local variables just to handle the smart casting.
If I may, I think in this case, using let would help.
Yes, you are right. It would. It depends how you structure it and whether yes, you are perfectly right. Let would work. It depends on the if condition, because I really make the condition simple so it fits into the slide. But you can have way more, bigger statement.
If the condition is something else than non-nullability, the let is basically not an option.
Yeah, I agree. But this is very simplified case for it. But otherwise, I agree that let would, in this particular case, solve it too. So anyway, the second thing was then when we had our service big enough that we need to kind of start slicing it into modules. So again, very similar approach. We've been thinking that if you define data class in one module and use it in another one, it would just work. But unfortunately, it is not working. Why? I haven't deep dived into it that much. It seems like that once you have a Gradle submodule and you compile it and you create the build artifact, it sort of loses the information that are Kotlin specific. So it treats it as a regular Java class, and therefore it doesn't expect that the smart casting should work automatically. So again, these are just two examples. There are way more examples of things where smart casting is not working. If you want to know more, look at the link. There are many of them listed. Next one that I want to talk about is KT-lint. Our goal, actually, at certain moment, of course, we had multiple services, we had multiple teams that are contributing to it, and we wanted to standardize the coding style within the source code. And also, we wanted to ensure that if we format our source code, it is formatted the same way in our development environment as well as, the integrated development environment like IntelliJ IDEA, and using certain code formatting tool like Kotlin. So when we evaluated 4 years ago, actually we found out that it's not possible. There was several formatting issues. For example, certain functions has been unindented. When you save it in IntelliJ IDEA, it was formatted differently than when you run it Kotlin format, and all these kind of issues. So we kind of revamped that and reiterated it 3 years ago, and then actually it was fixed. So since then we are using it, and would definitely recommend it because it's very nicely standardizing it, and we are not seeing any issues these days with the formattings whatsoever, at least for our source code. So since then we have it integrated, we are using it as a part of CI builds, in IntelliJ IDEA plugins and everywhere where it is needed. From the rules, we started to take it from the different angle. We started that we had our own code style that we wanted, and we want to adapt the Kotlin rules and IntelliJ IDEA rules to match our standard. So that's how we started. But throughout the time, the code style of Kotlin is more and more fitting what we want to have. And actually, we are even removing the original rules that we overridden, and we are just kind of having the core or almost natural as using Kotlin as is. The 2 only exceptions that I listed here are because we believe, as of right now, that they are still worthy of keeping and overriding the defaults in Kotlin. First one is using imports without asterisks, because it's good practice to explicitly list every single import explicitly to prevent any ambiguous imports. Especially, for example, you can imagine a list class in Java, AWT, and Java util. It's still the same simple name, and if you would have 2 star imports, it might potentially clash. So that's the first thing. And second one is still that we are having ability to have single file with multiple data classes or classes per se in it. Again, the reasoning is there because in our requests body and response bodies, it's bigger structure. It's not just a single class, and therefore we want to just collocate these classes because they are naturally fitting together. So that's the only 2 rules that we kind of overriding. Otherwise, we are sticking with the Kotlin by default. So 3 years. Sorry.
You wasn't talking about it, or weren't talking about it, but you're mentioning pre-commit hook. Could you elaborate slightly on that, since I can imagine it can be pretty slow, not only because it's running properly Java, but also basically the formatting can be on a huge amount of files pretty slow as well. So as a developer, I would be really annoyed. Well, so what is your experience?
I would say differently. Maybe you are annoyed, but it's pre-commit hook, right? And we want to ensure that the Git repository is really having common style. That's for us, it's more important. Readability is more important than writing the code. And second aspect is that you might say, I haven't personally experienced that Kotlin would be the slowest part of the whole process. Honestly, in our case, Kotlin is sorry?
Usually the commit is milliseconds. So.
Yeah, I know, but in your daily job, most likely you are just committing maybe, 5 commits per day or something. And I'm just, what we're seeing, and maybe you have different experience, but what we're seeing is that pre-commit hook, especially for Kotlin check, is taking, 5 to 10 seconds, maybe 15, roughly, So I don't think that it's that problematic, actually. Maybe it's because our machines are pretty cool, I don't know. Maybe. But again, I haven't experienced that issue. Of course, by the way, we are not using monorepo as it was stated. So in our case, maybe in your case, your code base is way bigger than ours. That's maybe another reason. Okay. So now Kotlin allows you to provide even your custom rules. Please take these as an example. It doesn't mean that you should be doing, or you can. You can definitely, but you should be doing it. But you can leverage Kotlin to provide additional rules that you establish in your organization to further protect your code. I already stated, there might be some anti-patterns that you know from your heart that are not good. In this particular case, try catch. Catching throwable is basically a big no-no in any Java space, right? You should not be catching throwables because it might also catch some system error, and you should not be catching the system errors. Another approach or another part where you can think of it is like, I've already stated how it is important to pass the thread local context and how much damage it would be if you will be improperly treating it. So you can just define a rule that will just guide this and ensure that you are not really leaking this. So it's definitely possible to do it in Kotlin, and why not to use it if it prevents issues. Another things might be that you maybe have some critical section that you want to really review on periodic basis, or maybe another rules that you want to apply. So you can, of course you can. But here I would like to explicitly state the limitation of the Kotlin. Kotlin is formatting tool, and for that reason, the only construct that it provides you is abstract syntax tree. So you get the syntax of the source code, not the semantics of the source code, which implies that actually it's easy to travel through the whole source code. But if you ask, for example, the scheduled, is it really Spring scheduled or is it some another scheduled? It will not answer you because it just knows this name. You would have to resolve it yourself using semantic tree. So I would rather say that this would be explicitly misuse of Kotlin, and it's better to use, for example, Kotlin has a Kotlin symbol processing API, which allows you to provide such semantic layer, and you will be able to resolve whether and what is the particular identifier used for, and what's the full qualified name. So that was for Kotlin. Next one, I'm not sure whether you are using Gradle, but most likely if you are Kotlin developers, you do, right? So even in our team, we started with Gradle from the beginning. Gradle is nice, when it's easy to read, it's small and easy to manage. But we experience throughout the time that there are too many frequent releases of Gradle. Especially if you compare it to Maven. In Maven, what you write there is most likely working forever, usually. With Gradle, they just releasing major versions once in a while, right? What is a struggle is that with that major changes, they typically provide certain documentation, but this documentation is not describing all use cases that you want to care about. So, which implies that actually you need to search how to fix your, upgraded build script, and you sometimes go for the forums, and forums are very, very often misleading. If not for something like they just forget about mentioning which Gradle version you should use for that advice. So even just that small thing, it just makes you to try and try several advices, and none of them is working. Of course, with Gradle, we are using even plugins. We have a couple of plugins to provide us several new tasks that are able to create some build artifacts. Everything works, exactly as you would like to. It's powerful enough to allow us to extend it. And again, there is some caveat. It works most of the time, but if you have a Gradle script which has these plugins, and you just, from command line it works, from IntelliJ IDEA it works, everywhere it works. But then you just start debugging your project, you deep dive into some library, and you would like to download the source code, and it stops working. Yes, of course, it's a bug. It's a small bug that you can fix, right? But these are small things that might happen, when you're using Gradle. Last piece that I would like to highlight, we are using modular convention, and I would definitely recommend to use it because it simplifies the whole Gradle scripts. It just makes it easier to have commonalities across your submodules. So just listing a couple of examples, but again, you can imagine that you can have way, way more than this. So next thing that we are using is mock-k, and the only statement that I have is just use it. We are very happy to using it. There is, nobody's even disputing that we should look at something else. It's just so great, and if for nothing else than just that any function that greatly improve and shows how the Kotlin is, having a nice system to derive on having these extension functions. It just shows the power of Kotlin. And last piece that I want to talk about today is specifically that I so far didn't mention Ktor. We are not using explicitly Ktor because we're actually using Spring. And the reasoning is behind it is twofold. First one is that actually Spring is very well known. There is usually some extension, some plugin, and there is something that it always, is there. Huge community around it. You are not alone with searching for advice or fixing your problem. So that's the first thing. Second one is actually that at least when we've been hiring, we hiring Kotlin developers, but typically we hiring Java developers instead. So we have typically the new hire person is Java developers. We would like to leverage their experience, and they are typically Java backend developers who knows Spring. So that was the second choice why we go for Spring. So with that, that's all what I wanted to show you today. So again, it started 5 years ago as an experiment. We still believe that the Kotlin was a very right choice that we made, and we really would like to continue using it. So if anybody is working in Kotlin and in Kotlin language and you would like to do some super cool new functionality, we will be happy to uptake it. So thank you.
You were mentioning that you are not using monorepo. So how you deal with sharing the build logic among the repositories?
Always libraries.
Sorry?
Build logic?
Yes,
Build logic. Well, build logic is done by external systems like, I don't know what all build parts you mean, but typically Gradle is specific for each project, and basically the requirement of the repository is that it is possible to be built, which means you just run, I don't know, Gradle W with clean build, it creates the artifact, and then we have Jenkins jobs around it to do it.
To do something like very same in the, let's say, 5 repositories, you just copy the Gradle code.
Yes, definitely Gradle build scripts, yes, definitely. But if you're talking about some plugins or something like that, we always make it as a library.
So just importing. So you actually have some internal Gradle plugins shared among the repositories. And then how you actually not plugins. Maybe that's my mistake. Not plugins. Anything like libraries, something that you can include into it. Not plugins. Specifically, not plugins that are in build sources that we are not using, or not sharing. Or let's say I want to have the same piece of something in the Gradle. Even I have a plugin for that. I copy this plugin among the repositories.
And that's what we do.
If, for example, something externally change, I need to fix it in all the repositories.
Unfortunately, yes, that's the same case.
Happy with that state?
No, we are not happy, but honestly, that's something that you just copy it only when you're introducing new repositories. We are not changing these plugins that often, because usually, we just crafted a couple of tools and we just have them. That's all. Actually, our plugin itself is actually not that super extensive. It's 300, 400 lines, and usually it has more code related to the particular service rather than some generic functionality. Because again, whatever is generic, we try to put it outside of those Git repositories. So for example, you can have Jenkins pipelines, which does the task for you in common fashion. So I don't know if it will be, upload to Artifactory system or whatever else, that's always external.
Outsourcing the stuff.
Yeah, deployment itself and the whole suite. Basically the service itself or the Gradle is just only doing the compilation and building one artifact from it.
Okay, thanks.
Do you delete feature flags sometimes?
Yes.
And if yes, why and when is the process?
So actually, deleting feature flag is good for your hygiene of the source code. If you don't do it, you are screwed. Period. We learned it very hard way. It's like at one moment you find out that you have a source code full of if statements, so you need to delete them, right? When you should delete it? Well, when you get the confidence that you can delete it. So you know that your scores, if you don't have that particular toggle switched or have ability to switch it off, you know that the code will always work. We are doing it because basically right now we have weekly releases, we have some certain processes that we are running on production that ensures that the particular feature is really working. So once we get the confidence, yes, we should be removing it. When exactly it is happening, it depends on the feature. It's not fixed time.
How do you handle Java and Kotlin updates?
Well, explicitly. So when there is a new Java, of course, there is, new Java, you need to have it a smooth process, right? So you have maybe certain version of Java, you need to have it in a Docker container, you need to add new Java version there, right? Then you need to update your scripts to be using the new targets and everything. So yes, it's a slow process because you need to make it backward compatible all the way. But yeah, we just handle it normally. I don't know what's specifically the question. Basically, yes, it's manual, tedious process that we need to go through. Yes.
Which versions are you using?
Well, I don't know whether I should disclose this, honestly. I don't know.
So last question.
Okay, maybe you mentioned that your ecosystem is composed of like several services that are sort of integrated. How do you sort of like test these things like on the different levels? Do you use some sort of like a contract testing in between or fully integrated tests all over on different environments?
Yep.
And possibly additional question to that, like how long is your sort of like quality assurance process for the release candidates before you sort of like make it released and continue like from the main line?
Understand. So specifically, that's why I was explicitly mentioning Sandbox, because this is for us as developers kind of unified thing that I can have all the services integrated and talking to each other. So that would be, I as a developer, I use Sandbox. If I would manually test it, then I would use it there. Typical most focused should be based on unit tests, functional tests, right? When you have this covered, then you go with the integration test. Integration test usually covers your feature, or your service against the others. Well, you need to have that environment that allows you to have this communication between. So that's exactly one of the environments that we have there. And of course, then you can have end-to-end tests on this kind of thing. So yes, Sandbox is one of them. Of course, we have additional clusters with additional confidence levels that we are using it as well. And we have huge suite of tests that we're passing through all of them. So yes, until it gets to production, of course, it's tested all the way. You ask how long the process of validation is happening. Most of the process is automated. So basically, it's just a matter of automation of the pipeline. I don't know exact number because I'm not in charge of that process right now, but I think that it's less than 1 day for automated part. Again, I stated that we are releasing on weekly basis. So every week we are trying to push the new bits, and those every single week we have the verified bits, right?
So to clarify, what you mentioned, like in the code lines, that you sort of like create this release candidate and do some sort of like a hot fixes and then release it into production. Possibly that takes like around a day, or
No.
for specific services that I get.
It can happen, but we are not doing it.
Continuously being released. That usually like the median is like with the fixes and stuff once every week.
Yeah, roughly once a week. Honestly, I don't know whether I can disclose exact numbers, but yes, it is not 1 day, and it is definitely no months, because actually we don't pipelining the releases. We just have the release, and we need to next week release another one. So there is certain pipeline, but it's not like for half a year we are patching this release, and then for half a year we are maintaining another one, which is overlapping. No, we really trying to have it continuously pipelined.
When you talk about release, is the release of the whole platform or just one service?
Each service is deployed independently. That's how it is done. Yes, of course, for example, when I was talking about maintenance windows are typically done across the whole Workday. Because you want to coordinate it. You don't want to say like your customers that one feature is working, these hours and another feature is different hours, right? So it's coordinated, and we just deploy the whole system, all the services, but actually each service can be and is independently deployed.
Thank you.
Okay.